between the United States and China may well be determined by computing power. We've seen over the last, 4 years, an increasing effort by the United States to flex its economic muscles in ways that are designed to hamper China's advance in this specific area. You go back to the entity list against Huawei. We now have the CHIPS Act, which is designed to promote manufacture of chips in the United States. And since your books since your book went to press, the Biden administration has issued new and far-reaching measures restricting China's access to intellectual property and, in effect, to Americans with expertise in this area. So give us your assessment of this strategic effort, which I've heard described as a pursuit of sci-tech hegemony by the United States. Do you think this is the right strategy, fundamentally, for the US to try and stop China catching up? And I guess it implies that China can catch up where the Soviet Union couldn't.
If you want to understand what the U.S. government's trying to accomplish, I think we need to return to the early stages of the chip industry, where there was a deep relationship, interconnection between military power and computing power. And although the United States has forgotten about this relationship because we've taken our military advantages for granted over the past 30 years, the reality is that any military system today is crucially reliant on computing power. And if you think of what it takes to, for example, fly a drone through a battle space. You're talking immense computing power to identify the environment, to assess threats that are coming in, to know where it's flying, lots of sensors, LiDAR sensors, infrared sensors, radar sensors, all of which require semiconductors to process the signals and send them to the the chips that are computing inside the drone. So military power is all about computing power. And that's important because the only advantage the U.S. has vis-a-vis China is that it's got better quality systems. And most of the quality differential is in terms of computing. If you ask yourself who's going to have a bigger Navy, the answer is obviously the Chinese. Who's going to have a bigger Air Force? Obviously the Chinese. Who will have more missiles? Obviously the Chinese. They're going to outcompete us tank for tank, ship for ship. And we know that, they know that, everyone knows that. The difference, as we see in the battlefields in Ukraine every single day, is that Western technology enabled by American computing works better. It actually hits its target. It's far more reliable. Our capabilities at intelligence, search, reconnaissance are far better than the Russians, which is why the Ukrainians, with just a handful of HIMARS systems, have been able to turn the tide of the war in a way that the entire missile arsenal of the Russians, almost all expended at this point, have failed even to knock out Ukrainian telecoms infrastructure, which is sort of a horrifying failure if you're a defense planner. And that differential, there's a number of different factors at play. Russian morale is bad, et cetera, but ultimately, U.S. weapon systems work better because they have better computing behind them. And if you ask yourself, how can the U.S. retain its position in Asia or really prevent the deterioration of the military balance in the Taiwan Straits, there's no story you can tell in which the U.S. is going to have as many ships or missiles or tanks as the Chinese. The only advantage we've really got at this point is the advantage in computing power, and that's what the Biden administration is trying to defend.
And that leads me to the first of our questions from the floor, and thank you to all of you who've given us questions. Biden's chip policy will hurt China in the short term, but in the middle term, won't China develop its domestic industry and market to replace what we've taken away? That's the big question. Won't they just catch up faster by being shut out in this way? What do you think?
Well, they're going to try, but it's going to be enormously difficult. The machinery needed to make advanced semiconductors is the most complicated machinery ever invented. So a chip on your iPhone will have 10 or 15 billion transistors, each one the size of a coronavirus, actually slightly smaller. And the tools needed to produce coronavirus-sized transistors by the billions are mind-bogglingly complex. Just to give you one example, one of the tools you need is called a extreme ultraviolet lithography tool, which costs $150 million a piece, took 3 decades to develop. This tool has the flattest mirrors ever invented by humans inside of it, one of the most powerful lasers ever produced for commercial purposes inside of it. So many components that the company that produces it doesn't know the number inside of it. I have multiple interviews with them. I've asked them. They know that the laser component alone has 457,000 components, but they don't know the aggregate number. And this machine has constantly explosions of several 100,000 degrees Fahrenheit inside of it, inside of a manufacturing facility, and is able to contain it all and produce just the right amount of extreme ultraviolet light to carve coronavirus transistors on chips. This is not easy equipment to replicate.
Who builds those?
This is built by the Dutch company called ASML, which has a 100% market share in this equipment.
Yeah.
And if you look...
Remember those initials, ASML, like almost up there with TSMC in terms of its importance in this story, and it's like the most important company you hadn't heard of until tonight.
And if you look across the types of machinery needed to make advanced semiconductors, many of which are still produced and assembled here in California, what you'll find is machinery that is that complicated at every step of the production process. Moreover, this machinery is all developed, and next generations are developed in close consultation with the small number of leading chip firms. So for example, the equipment firms that are building this equipment, they'll make their next generation machine working with TSMC, Samsung, and Intel, because the machines will only work if they're perfectly matched to these companies' processes. And these companies' processes only work because they're perfectly matched to the next generation machines coming online. So if you're outside of this loop, you're far, far away from the cutting edge. And as of right now, every Chinese firm is outside of the loop.
I actually met Morris Chang 2.5 years ago in Taipei. We had a memorable meal together, and I asked him the question, can mainland China catch up with TSMC? And he replied, they are 5 years behind us, but they were 5 years behind us 5 years ago, and they'll be 5 years behind us 5 years from now. So he's absolutely shared your view that this catch up was impossible.